Hi everyone, this is Britjet's PSX Tips, the Aerowinks PSX 747 desktop simulation. Today I'm going to talk about the takeoff ref page. Before I start, I thought it'd be an idea to show you my model if anyone's following it through. It's a long-range BA 747 with RB211 engines. There's the airframe page. Equipment looks like that. And programming. There you go. Right then, where shall we go? Well, I thought we'd go to San Francisco. 28 left. It's got a hill on the end, which is quite handy because it enables us to put some different figures in the takeoff ref page. The aircraft today is set up performance-wise like this. It's ready to go to London at typical weights. You can still derate at those weights, and we'll look at that momentarily, how we're going to do it. So we need to put in a temperature. You remember, if you watched the previous video, that there's various ways of doing that. I'm going to use the table very briefly here to point out a couple of things. This is 28 left at San Fran, flap 20. The black box at the top with min Axel height 1500 feet. Well, it makes a lot of sense because there's a hill out there. Coming down to the bottom, the text says emergency turn procedure. An emergency turn is something the crews follow if they have a performance problem on climb out, such as an engine failure, and they can't follow the climb out minimums. And it will typically be an alternative route as a gap between hills or something like that. A professional crew will always have a picture in their minds, and also probably on the nav display, of what this entails. They'll do it with fixed page, using bearings, the NavRad page using radials, and might also use route 2, although that can be a little bit messy. This particular one is fairly straightforward. For an initial failure, you just carry straight on up the center line, really. The third dimension to this is the height for cleaning up, and you'll see that it mentions there a min Axel height above threshold in brackets of 1500 feet. So it's 1500 if all the engines are working for the cleanup, and it's the same if an engine fails in this particular case. Many airports will have very different ideas on how to do this. Now then, let's just get our temperature out. We're taking off from a weight of 364, and on our table there, if we move along to the left, you can see we have an assumed temperature derate available of 40 degrees. So I'm going to put that in the ThrustSlim page. It defaults to climb 1. I haven't been told to use anything else, so I'm going to keep it, and you see that the system has gone to DTO 40 degrees with an EPA of 1.63. This was on the previous video. Great stuff. Now we get to the takeoff ref page. Now I could use all the performance that's on the table here, but I'm not going to. What we're going to do is we're going to use the FMC primarily for our takeoff calculation. I'll show you how that's done. First of all, we know we're going to do a flap 20 takeoff in this case. My airline always did. You may have other ideas, that's fine. You'll have heard of airports insisting on something like V2 plus 10 for noise abatement up to 3000 feet maybe. That would go in the box like this. Like that. That's a height. Now all the heights on here are heights. They're not radalts as such, and they're not anything you can see on your barometric altimeter in front of you either. They are taken above a reference snapshot the aircraft takes when it's going along the runway. At 100 knots it records the pressure, and then these heights are taken above that. Now today we know that we had 1500 feet for an all engines acceleration, so that would go in like that. Next line down, engine out Axel height. 400 feet is the default. You'd be a brave man, I think, to do that. Most airlines will use 1000, like that. You can overtype it for any departure by 1000. Today we know the figure is actually 1500 feet. Incidentally, that default figure can be changed through the performance factors in a more permanent way on your FMC. Have a look at page 362 in Hardy's manual, it will tell you how to do it. Next one down, thrust reduction. Flaps 5 is the default. We weren't told on the performance data there where to reduce the thrust in particular, so I'm going to leave it like that. When we get to flaps 5, the power will come back to the preset climb 1. Now, of those 3 figures in there, the engine out will override the others if you have an engine failure. It will recognize a failure and the system will throw away your noise abatement, throw away your thrust reduction, and it will simply accelerate for you with full thrust, or sorry, with derated thrust, or whatever thrust you had for takeoff actually, at the engine out accel height. So that's those. Next 2 down are rather clever. They're not on BA aircraft in an operational sense, but I like them because they will enable you to do a performance calculation just using the FMC in PSX. The aircraft has all the data it requires to do a takeoff calculation. It knows all about the runway characteristics, knows about the weather, knows about the condition and weight of the aircraft. It doesn't know about obstacles which might be in the climb out, but as long as you've taken account of those in some way, or you're prepared to accept that there aren't any, then you can use these 2 lines to just to produce the only takeoff performance you need. So for example, if I give a headwind of 20 knots, watch the V1, you see it will actually increase a little bit, which is great. Similarly, you can do things with the slope. If I put down 1.5, again the V1 will change. So you can play around with those figures, and they're very useful. Next one down, runway conditions dry. I think everybody understands that. Wet, however, now wet is seriously soggy. It's not just damp. We are talking about a runway that's just survived a huge downpour, might be as much as 1/4 of an inch of rain set in puddles at various places along the runway. Wet is thoroughly wet, but you're allowed to use it in those conditions to change your V1 and make a stop more comfortable if you decide to stop. The dry V1 there will give you a comfortable clearing at the far end of at least 35 feet. If you go for wet like this, the V1 comes right down now. It's gone to 137. That's great, because if you decide to stop at 137, you've got there quicker and you've therefore got more runway left to stop in. Perfect. But the height you can get to at the far end of the runway will now be reduced because you're carrying on the rest of that takeoff with less thrust if you have an engine failure. So they allow you to come off the far end at only 15 feet instead of 35. It's a bit of a risk assessment thing, and it's prejudiced in favour of stopping the aircraft on a wet runway. But we'll go back to dry because it's a nice day here in San Fran. The V1 is protected from putting in silly speeds, in particular from the VMCG, minimum control speed on the ground. So if I put in something crazy, like that was crazy, like this, it will come out with that figure and say, that's the minimum, mate, that's all you're getting. The VR will be set a few knots below V2 depending on the aircraft weight. It's typically anywhere between about 7 and 12 knots below the V2 speed. So don't worry about that, just leave it where it is. It could be the same as V1 in many cases if you've got a longer runway, of course. The V2 is the flap 30 VREF. Now, the PSX system simulates a GE engine for the purposes of the PC simulation, which is pretty good, but you might find that it's slightly at variation with other engine types. But if you want to check the flap 30 VREF is equal to that, go to Index Approach, and you'll see it quotes 175, which is within a knot, isn't it? That's a cross-check. The other cross-check that's really quite important, and crews will do this, is to look up the V2 in a table before departure and look up the flap 30 VREF in a table before departure and set it on the MCP at the top there like that. Then when you come to fill in the takeoff ref page, you can compare the two values and make sure you're within a couple of knots of it. If not, something's wrong. Then when you've done that, put the V2 from the MCP in the top there like that. It's important to do that because the flight director uses the MCP speed for the climb out. Once you've done all those, hardwire the speeds, make them bold, and that bit's ready to go. Next line down, trim and CG. This is percentage MACTOW, M-A-C-T-O-W, mean aerodynamic chord at takeoff weight. You'll get this from a load sheet typically, and it will be somewhere between 17 and 22% for a passenger aircraft. So if I put in 20 there, for example, after a few seconds it will come up with a trim setting which I put on the pedestal. There it is. That's one way of doing it. Now you may not have access to an MACTOW, and what you can do therefore is get your own by use of a system which is on the aircraft. To do this, go into the airframe section, and I'll just bring that up for a second, and where it says weight and balance system, select single or dual for that matter, like that. Now when you go back into the FMC, you will see that we've got a CG suggested of 20%. It's done on a check of the nose wheel, the weight on the nose wheel. So if you're happy, you can take that like that, and again it will give you a trim setting. Last one down, pos shift, so many meters. If your GPS is working, that is irrelevant. If your GPS isn't working, then this is a way for the aircraft to update the aircraft position as you take off. And basically as you hit the toga switches on the takeoff roll, it updates the position on the FMCs to the landing threshold position. So obviously if you're going off from an intersection, you're going to fool the system. You don't want to do that, so again, only if the GPS isn't working, you would put in how many 100 meters you are up the runway if you're using an intersection. So 300 meters up the runway, like that, put it in. When you press the toga button, it knows how far up the runway you are, and it will update the system accordingly. Lastly, when you've done all that, select your LNAV and your VNAV as you want to for the departure, and you're done. I hope that's of interest, and the last two videos are a little dry. We'll probably make something a bit more interesting next time. I'll probably be talking about go-arounds. Thanks for tuning in. Bye for now.